Hello guys, in this video I'm going to show you how to solve subsets with duplicates. So given a set of numbers that might contain duplicates, find all of its distinct subsets. Right. So for given input of 133 with empty 1 3 1 3 3 3 1 3 3, right? So it's very similar with our previous problem in this category, right? Our previous one is distinct subsets, but with no duplicate, right? We've solved it in two different ways, depth first search and breadth first search. In this video, I'm gonna solve our problem using breadth first search. Let's see the difference here, right? The difference here is that our input, right? Our set of numbers can contain duplicate, right? In our previous problem, right? As you can see here, we visualize as a tree. So we initialize with an empty array, right? At each level, we try to add. We try to add more subsets, right? With one number, right? So our input is 3. We have 3 numbers. We have to we need to iterate for every number. So each number is corresponding to one level of our tree here, as you can see. And initially we have one subset, right? So at level 1 we take out that one subset, push the number at current level, which is 1, to the subset of previous level. So we put on here, then we have this new subset, right? Again, same logic here. At level 2 we need to add 3, so right. So for subsets of previous level, we keep the same here, right? And we need to, for each subset, previous subset, we need to create a new subset with the number of current level, which is 3. So we add 3 here. We got 3. We add 3 to this one. We got 1 3, right? So simple as that. Same logic here. But now our input can contain duplicates, right? So for example, this level is 3. We need to add 3. Our input here is O3, for example. So we still keep the same 4 subset as the same as previous, and we add new subsets here. So what we have here is the first one, we add 3 here. Okay, we add 3. Add 3 to this one, 1 3. Add 3 to this one, 3 3. Add 3 to this one, 1 3 3. So what's wrong here? As you can see, we have duplicates subsets in our result, right? We have 3 and 1 3 is duplicated here. We don't want this, right? So to solve this problem, we need to consider the case that, as you can see, the problem occurs when the number of this level is equal to the number of previous level, right? So if this is the case, then we need to do something different. Actually, the one that the new subset, the subset that cause duplications is coming from this one. This two one will produce the two subsets, which are duplicates, obviously. So we probably just want to add 3 here to these two, right? So what's the difference between these two? So these two are two subsets that was added from previous level, right? This level, these are the same as level 1. So we need to somehow limit the subset to process here, right? So probably we just want to iterate to, we don't want to iterate to everything in here, just want to these two subsets, right? So that's the idea. Let's code it out. But before that, let's try to run to our example. Let's delete this. Okay. What kind of variables we need to declare here? First one is the list of subsets. Initially we have one subset, right? Initially we have one subset, right? So at each iterations we probably want to take out that one subset. We need to limit. In the previous program we run for each iteration we want to run to everything in the list, right? Every element in the list. But now we want to limit only the subset that was added in previous one. So the idea here is to keep 2 pointers, right? For example, at first we have 2 pointers. At first we have only one subset, right? So we need to, of course, process that one. So initially our 2 pointer just point to this single subset, right? So the current one we process E. Let's say here is the start and here the end, which is limit the range of subsets that we're about to process. The current ones is of course the single one in here, right? Okay. The number. One more thing. Our input can be out of orders. So because we want to have equal numbers sitting next to each other, we probably must first to sort our array so that these two numbers are next to each other. We sort it in ascending order. So okay. Okay, our current array is our current subset A, this one. Okay, our first number to process is here. Okay, so we add the current number, which is 1. Current number is 1, right? So we add 1 here. Okay. So the new subset is added to our list of subsets, right? Okay. So our current pointer here. So we're done with this batch of processings, right? We have only one to process. So as we process, we add new subsets to the list, right? So now we want to update our start and end pointers. The start will be n plus 1, right? We want to start process from here. Wait a minute. There are two cases. If the current number is, for example, we are here, then our current numbers is equal to its previous number. So we only in that case we will process only part of the subsets, right? But for now, because the current number is 3, right? It's different from 1. So our start is 0, right? Our end is the final one, right? So we start from our head to the end. So the first one is again empty. The current number is 3, right? So we add 3 here. Okay, we push the current to the add new subset here. Okay, move to the next one, which is 1. Current 1, right? We add current number 3 to here, which is 1, 3. We update our list of subsets with 1, 3. Okay, so we're done with current batch, right? Okay, we move to the next number, 3, which is a duplicate of previous. So the start will be here right after the next, right? So everything after the end pointer is the node that is previously added, so we only want to process that part, right, but not all. So okay, we update the pointer, we start here and end at the end of this, right? So we start here 3. Okay, the current one is 3, the current num is 3 also, so we add current num to current, we got a new one, 3 3. Okay, the next one is 1 3. Okay, we add 3 to 1 3, we have 1 3 3. Okay, we've done with this batch, right? So at the same time we done with our list, our input, right? So we exit and return this as result. So that's pretty much it about our algorithm. Let's start to code it out. Okay, we need to sort our number first in ascending order. Okay, after sorted, loop every number in nums, right? Okay, let's sort it first and initialize what is that, subsets, how to call it, instant file subset, list of subset, right? Let's say result list of subset, which is what we will return after processing. Return result. Okay, initially we have one subset which is an empty subset here, right? We need to keep 2 pointer to limit what to process in the next iteration. So for the first iterations, start is 0, right, and end is 0. So we will process exactly 1 from 0 to 0. But we will update these as we go along. So sort number in ascending order. So nums dot sort. We sort in place using the built-in function of JavaScript. A minus b. This will sort our nums in ascending order. Okay, initialize our result. Okay, start at 0 and 0. Okay, look for every numbers in nums and okay, add new subset at this level, at current level. Oops. What we need to do here is for, because we need to have access to the previous number, right? So I'm gonna use a traditional for loop. Let I equal to 0, I less than nums not length, I plus plus, right? Oops, what's wrong here? 4, right? 4. So let current num is what is num I So if what want to check the previous number to limit our start and end. So if for the first number we don't have previous number, so if I greater than 0 and I kernum is equal to previous num, which is num at I minus 1, then where I want to start? I want to start at n plus 1. Okay, so down here for each number we wanna loop, wanna iterate from start to end, right? Equal to start. For let j equal to start and j less than n, then j plus plus. Okay. So for we get out the kernel subset. Kernel subset is result dot at j. So new subset will be we spread out the subset, kernel subset, and add a kernel. So we got a new array that without modifying the previous this subset, right? So the new subset. Okay. We got new subset. I'm gonna push it into result push new subset, right? Oops, new subset. Here we need to update the n as well. The n is the last element of the current list of subsets, right? N is equal to result dot length, because here is let's okay, so let's use a index instead. So n is minus 1, so we want to run to the end, right? So that's it. Okay, we take out the current subset, right? We create new subset and push it to result. Come back here. Okay, we got a new number. Okay. Check them if it is equal to we need to reassign it here. Start it equal to 0, right? So if it is not this guy, which is the kernel equal to previous num, start could be 0, right? For the start for everything inside the result list, right? N will be length minus 1, which is the last index, right? So that's it. I think it's let's see. Okay, it works. So thanks for watching, see you in the next video.